Imagine the weight of a heavy iron mallet resting in your palm, its surface cool and pitted from decades of use. This is the tactile history of the early industrial age, where the balance of a tool was as much a science as it was an art. We begin our journey by examining the distribution of mass in the 1840s broadaxe, a tool designed for endurance and precision. The early 19th century was a time of transition where the raw power of the forge met the emerging logic of mechanical engineering. When you hold a tool from this era, you are holding a physical record of the blacksmith's intent and the laborer's necessity. The weight is never accidental. It is calculated to work with gravity, not against it. Consider the density of the metal itself. In the years before the Bessemer process revolutionized steel production, tools were often made of wrought iron with a thin laminate of steel for the cutting edge. This dual material construction created a unique weight profile. The wrought iron provided a shock-absorbing body that was tough but not brittle, while the steel edge provided the necessary hardness to maintain a sharp profile. This contrast in materials meant that the center of gravity was often shifted toward the business end of the tool, allowing the weight of the hammer or axe to do the work for the user. As you run your hand along the handle of a 19th century framing hammer, you feel the subtle taper of the hickory. The wood is dense, seasoned over years to ensure it does not shrink or crack. The handle is not merely a lever, it is a counterweight. The blacksmith would carefully shave the wood to ensure that the point of balance rested precisely 2 inches below the head. This specific placement allowed for a rhythmic swing that could be sustained for a 12-hour workday without causing the shoulder to seize. The swing becomes a pendulum, a natural extension of the arm's own mechanics. In the quiet of the old workshop, the only sound is the rhythmic thud of the mallet hitting the chisel. Each strike is a testament to the tool's internal geometry. The chisel itself is weighted toward the tip, allowing for a steady follow-through as it bites into the oak. We move now to the carpenter's plane, a block of rosewood or cast iron that seems surprisingly heavy when first lifted. This weight is intentional. It provides the inertia necessary to glide through stubborn grain and across heavy knots. The center of mass in a jointer plane is kept low to the bench, ensuring that the tool does not tip or chatter as it creates a perfectly flat surface. The iron, or the blade, is held at a precise angle, often 45 degrees, which works in harmony with the tool's overall heft. You can almost feel the heat generated by the friction as a long, thin curl of wood spirals away from the mouth of the plane. The smell of cedar and linseed oil hangs thick in the air, a scent that has lingered in workshops for centuries. Moving to the machinist's bench, we find the calipers and the scribes. These tools are light, almost delicate, yet they possess a balance that allows them to rest easily between the thumb and forefinger. The steel is polished to a mirror finish, reflecting the dim lantern light of a Victorian factory. Here, the weight is distributed for sensitivity rather than power. The machinist must feel the thousandth of an inch, a tactile feedback that is only possible when a tool is perfectly balanced. Even the heavy monkey wrenches of the mid-1800s were masterpieces of ergonomic thought. The forged iron handle was often thickened at the grip to provide a more comfortable surface for the hand, distributing the pressure of a hard turn across the entire palm. The adjustable jaw moved with a heavy, satisfying click, a testament to the precision of the threaded screw. We must also consider the blacksmith's anvil, the silent partner in every tool's creation. Its massive weight, often hundreds of pounds, was necessary to provide a stable foundation for the violent energy of the strike. The rebound of the hammer off the anvil's face is a study in efficiency. A well-balanced hammer will practically lift itself back into the air, ready for the next blow. This elastic collision saved the smith's energy, allowing the work to continue from dawn until dusk. The transition to mass production in the late 19th century began to change the way tools felt. As factories replaced individual smiths, the subtle variations in balance were replaced by standardized weights. Yet, the principles remained the same. A tool must be an extension of the body. The early industrial era was a golden age for this philosophy. Every curve of a handle and every ounce of a tool head was a deliberate choice. As the sun sets over the imaginary workshop, the tools are cleaned and coated in a thin layer of oil to protect them from the damp night air. They are placed back in their chests, their weight pressing down on the felt-lined drawers. The silence returns, but the memory of their balance remains. You can feel the phantom weight of the hammer in your hand, a steadying presence that grounds you in the physical world. The rhythmic nature of the work, the steady swing, and the consistent weight all contribute to a sense of calm. The mind begins to settle, mimicking the steady, predictable physics of the workshop. There is no hurry here, only the slow, deliberate movement of metal against wood. The complexities of the modern world fade away, replaced by the simple, honest weight of the past. Each tool tells a story of a hand that held it and a task it completed. The balance of the tool becomes the balance of the mind. You are drifting now, much like the shavings from the plane, floating slowly toward the floor. The weight of your own body begins to feel like the heavy iron of the anvil, solid and resting. The world is quiet, the forge is cold, the tools are at rest. The industrial age, with all its noise and fire, has settled into a peaceful, rhythmic pulse. You follow that pulse deeper into the stillness of the historical workshop. Everything is in its place. The balance is perfect. The weight is exactly where it needs to be. As you close your eyes, the last image you see is the glint of steel in the moonlight, a silent guardian of craftsmanship and peace. Discover more history by watching the next video. We're eager to share more with you. You can't go wrong. All our videos are deeply detailed, dull while fascinating, and distinctly sleep-inducing.